Hey everyone, my name is Anvita Bansal and I hope we are live. Just let me know in the chat if you guys are able to see my screen and if I'm audible to everyone. Are we live, guys? Okay, great, good to go. Okay, Sushant Kumar. Okay, I think let's start with you only. So I think you are very frustrated with girls being into software industry. Is that the thing? Shall we check what you do? Can we know your user ID on LinkedIn? Can we know what are you up to in your life these days? I think this is very offensive comment and you should refrain from saying this unless you know what people do to get into where they are. Okay? So stop this frustration, work hard on yourself rather than commenting on what people are doing. I'm sorry we are having to start this contest session on this note, but I think this is not right. Okay. I don't take it, guys. Varshit, whatever. So let's start off with the question. Okay, guys. So the contest was definitely easy today. And starting off with the first question, naughty geek. Okay. So let's see the question. Very simple question. I'll explain you what this question is about. So the geek has gotten an offer and he has total n days and n people to meet, right? There are n different friends of geek who he wants to meet on n days, right? The question is that the person cannot meet the same person again. It cannot be repeated, right? So I'll just explain you simple mathematics. Actually, this is a very simple 12th class question. You have n days, right? And different people, okay, and different friends, you can say friends, and the person wants to meet each friend on each day. That is, he has n different days. Let's take an example of 3 days. Okay, if the person has 3 days and 3 different people, right? So that means if I start from day number 1, let's start with day 1. Easy question. I'll just explain you and you'll be good to go that what is to be done with this. Now, see, when we have 3 days, I am starting with day 1. The geek wants to meet three, there are total 3 people. Let's say P1, person 1, person 2, and person 3. Fine. If he chooses to meet P1, now he will be left with 2 people. But he has to actually choose among 3 people. So he has 3 options as of now to meet on day 1. You got it? So in how many ways? You remember how we used to do permutations and combinations? Permutation, it's simple permutation question. So I want to choose one out of 3%, choosing one from 3 people. So how we used to do, you remember NCR, where N is 3 and R is 1. That means choosing one from 3 people, I have 3C1 options. And 3C1 gives me what? Its answer is 3, exactly equal to 3. So day 1 has, when person wants to meet on day 1, he has total 3 options, right? Now, for day 2, let's say, why we have 3 options? Because he can choose to meet P1, or he can choose to meet P2, or he can choose to meet P3. Now when day 1 is over, now when day, let me check if you guys are able to see my screen. Are you able to see the board? Let me, just a second, guys, were you able to see my board or not? Oh, okay, I'm sorry, let me just reshare my screen, guys. Wait, just give me a second. Okay, let me know if you guys, I think it's okay now. You guys are able to see my screen. I'll just reiterate again. I think you already heard the logic. So what I've written is that you have 3 days and 3 people. On day 1, I will have 3 options. Why? Because I have 3 people to choose from, right? So how many ways I can choose one from 3 people? That is 3C1. Now let's go on day 2. For day 2, one thing is sure, that one out of P1, P2 or P3 have been gone, means you have, the geek has already met one of these three people. So that can be anything. If let's say, for example, in how many possibilities he can choose one person from three people? Three ways. Why? Because he can choose P1, or he can choose P2, or he can choose P3. In all of the ways, we know one thing for sure, that for day 2 we will be left with only two people total. So those two people can be anyone in any combination of, it can be P1 P2 also, or it can be P2 P3, or it can be P1 P3, right? It can be any of these three combinations. So the point is, now I have to choose one person from two people. So how many ways it will be? It will be selecting one person from two people, that is 2C1, exactly equal to 2. So day 2 will have two options, and for day 3, now I'm left with only one person, and choosing one person from only total one people will be 1C1, that is equal to 1. So if I talk about three people, I have 3 days to meet, and no person can be repeated, right? If once met, I cannot choose to meet again. So there will be total how many ways? 3 into 2 into 1. That is basically 3 factorial ways. For any question, you will understand that it comes down to actually calculating factorial for n. So that is 3 into 2 equal to 6. You got it? Did you understand this question? Guys, are you able to understand this question? This simply comes down to number of ways to choose n people, one people out of n people. That is NCR. NCR, where n is equal to 3, for example, here, and r will always be 1, because you're choosing only one person at a time. Simple thing, it's nothing. And NCR is equal to what? Factorial of n divided by factorial of r divided by factorial of n minus r. If r is 1, the question will be left down to calculating factorial of n. And if still you have any doubts, if you have any doubts, let me know. I will move to the other question. If not, I'll just one example I will take. For example, you have P1, P2, and total 2 days, right? So how, in what combinations can you meet those people? So I'll just tell you. I am saying that if you have, let's say, two people, so there will be total 2 factorial ways, that is 2 into 1 equal to 2. And how are we coming at this solution? This is as simple as this. This is day 1, this is day 2, this is P1, right? What combination? Let's say I have P1 and P2. On day 1, I am choosing to meet P1, so I will be left with only one person to meet on day 2, that is P2. This is one possible way. Another possible way is I am choosing P2 on day 1 and P1 on day 2. So how many ways are these? One, this is one solution, this is one solution. Total 1 plus 1 equal to 2 ways. You can try this out for 3 people, you will understand how you're getting 6. Okay, I think I started considering permutation. Yeah, you are right. It is simple permutation question. Now let's move to the other problem, which is max array. So let's see what is this question about. Max array is also not too difficult question. Actually, not at all a difficult question, just a simple observation based question. So what this question says, that you are given an integer n and an array of n positive numbers. Convert this array to hold either of the following condition by performing some, possibly 0. This is your question. Basically what you have to do is, either there is exactly one maximum element in your entire array, or if you have more than one maximum elements, those elements should be present in consecutive order. That means they should be present one after the other. So the target of this question is that you are given an array, and if you have only one maximum element in the entire array, then you don't have to do anything. For example, in this question, you see what elements you have. You have 1 2 3 2 1. What is the maximum element of this array? Only 3. So you don't have to do anything. No operations are required, because operations are only required in the case where you have more than one maximum element. The maximum element was 3 and it is only present once in this array. So you don't have to do any operation. But if, for example, in this example, what is the maximum element? 5. And how many times it is present? It is present 2 times. So what you have to do is, you have to, if there are more than one maximum element, then all maximum elements should be adjacent to each other. Now you see that these two fives are not adjacent to each other. Now what operation you have to perform? You can choose any element of this array and make it its current value -1. Only this operation is allowed. And now you have to tell in how many moves, basically in how many operations can you do this thing, so that you achieve that the maximum element of the array is exactly adjacent to each other, consecutively present. Got it? So for example, if I have 5 here, I have 5 here, what can I do? Something, I have to do something so that the maximum element is present together. So what they said here, we can apply operation on second element, and array becomes like this. Second element is this. What they have done, they have converted this element, they have applied operation on this element, and the operation says that you can make the element 1 less than its current value. So when I made this element 4, as you see here, now you can see that in the entire array I have only one maximum element. So you will always have two possibilities. See, first, there are two things to understand here. In question max array is the name, right? Let me check if you guys have any doubts. Okay. So for max array problem, what do you have is, you can perform one operation if you have max elements present in your array which are not consecutive, means not adjacent to each other. If that is the case, you can do two things. First of all, the operation will be one. By doing that operation, and operation is only, the only operation you can do is convert the current element to its value, subtract 1 from it to make this value of the element. That is the operation you can perform. So when you perform this operation, you can have two things in your array. One is that either you get only one max element in the whole array. That also solves your purpose. And another thing is that you apply this operation in such a way that all max elements are present adjacent to each other. All max elements are adjacent. Fine. So these are the things that you can, this is the only thing that you can perform. And what are the results you can get? You can get either, there is only both these two cases are acceptable. So that is how you have to modify your array. Now the answer that you have to return is how many minimum such moves will be required, or minimum operations required, so that we can achieve either this or we can achieve either this. Okay. Now see, the first step in this question will be, that, where is it? Max array. That first of all, your target will be to find the maximum element of the array. Fine. Once you find the maximum element of your array, you will check if that maximum is present only once or more than one times. So for that, I will keep a track. As you see here, I am running a loop over this array to check the maximum element in my array. So from this, I will get the maximum element is 5. Now what am I doing here is, I am creating an array list in which I will be storing the indexes at which the maximum element is present, so that I can know if they are adjacent to each other or they are not. So what I have done here is that take another array list, create another array list in which from the given array you check at what index the maximum element is present. So your new array that you will find, I will do a dry run with an example on the blackboard. Just right now I'm just making you go through what we are doing using this code. Okay. So now when we have this array, it will have index 1 for this 5 and index 3 for this 5, right? So this will be your array P. That is what we are doing in this loop. Now the next thing I'm just conceptually telling you what we are doing so that you will understand when I iterate this on the blackboard. Okay, now the next thing is that we are iterating over this p array list. So p array list consists of only the indexes at which the maximum element is present in my given array, right? So there I'm trying to find out the count of consecutive indexes, so that I can know if that count, see this count is 0 right now. Okay, this is some any negative number that I have taken just for the comparison. Your indexes start from 0, right? So this is any negative minimum. I want to take a minimum element. That is why I've taken -5. You do not have to get confused. You can take anything. It can be -1 also. Just that this is the minimum for comparisons of your indexes. Now you are iterating over the elements present in P. So the elements present in P are what? Indexes of the maximum element in the array. If your current element, right now I am at index 1, I am checking, is this index equal to previous plus 1? So previous was this. Basically, I am trying to check if the current element at which I am, that index is adjacent or the next index of my previous index. So basically this condition will not hold true right now. I will go to the else part. I will check. I have to also keep a track of the maximum series of consecutive indexes, so that I can know what is the minimum number of operations. And how will I get to know? I'll just tell you. Let me take an example only. I think this much is clear to you. I'm taking the part from here and I'll help you understand what we are doing from here. Okay, just wait for a moment. So see, let's say this is your code. Fine. And what we have is, we have an array like this. A given array was this. Then I will create a p array. 1 5 3 5 4. 1 5 3 5 and 4. This is your given array. Now the next thing is, I am creating another array list P. First I will check which is the maximum element. I will get to know that 5 is my maximum element. Then I will iterate over this array and check at what indexes this 5 is present. I will store those indexes in P array list. So P array list will have the index of this 5 and another 5. This is 0, 1, 2, 3, 4. Index 1, index 3. This is what your P will hold. Fine. Okay. Now the next thing what we are doing is, now have a look at this. Initially your count, see how I will be updating. Your count is initially 0. So count will be storing the count of consecutive indexes that I will find in P. For example, if P was something like this, right? So the count will actually be equal to 3, because this is the count of consecutive indexes, and the count of consecutive index count for this will be 1. Then this answer which you see here, it will store what is the maximum consecutive series of count. So from here I will get count 3, from here I will get count 1. How? You will understand that thing. And then answer will store the max of these, so that will be 3, to tell me that what is the consecutive series of indexes where I am getting the maximum element. Okay, so initially your count is 0. We are taking previous as any negative element. Here it is equal to -5 and answer is equal to 0. Now we start iterating over this P. First element is index 1. I will go to the else part. Answer will be equal to max of answer and count. Answer is 0, count is 0. So answer is still 0 and your count becomes 1 now. Fine, your count becomes 1. And your previous becomes equal to x. What is your x right now? X is equal to 1. So previous becomes equal to 1 in this case. Fine. Move to the next element of P, which is 3. So for 3, I will check if it is exactly next index of what I found in previous. So previous right now is 1. Is 3 equal to 1 plus 1, that is equal to 2. That means I want to find if it is like a consecutive integer, consecutive index. No, it is not. So basically what I'll do, it is not. I'll go to the else part again. My answer will be max of answer and count. So count right now is 1. Answer will become 1 because answer is storing the maximum consecutive series of indexes. Why? Just wait till here. I will tell you why we are doing so. Now your count again becomes 1. The reason is This is another series of indexes which starts at 3, assuming that maybe I can get consecutive set of indexes further, because after one I wanted to have two. If I could have, I wanted to satisfy that condition of adjacent maximum elements, but since I did not get a 2, I am hoping that maybe after 3 I can get a 4. So for that, again, count will be 1 for this case. Now, end of your iteration, come at this. Answer will be max of answer and count. Basically, your answer will be 1 only. And for now, the answer that you have to return will be actually equal to this length, array list dot size 2, minus what is the answer stored in your answer variable. That is what you will return. Why have we done this thing? This is something you need to understand. Let's take another example, a simple, just this example, then you will understand why are we doing so. For example, if let's say your p array was this 1, 2, 3 and 5, right? So this indicates that at these indexes in your given array, I have the maximum element. For example, your max is 8, for example. So what it suggests, this p tells you that index 0, index 1, at this index also you have 8, then at this index also you have 8, at this index also you have 8, then at 4 index there must be some other element, and 5 index also you have 8. Now what I'm doing, I'm iterating over this p array and checking what is the maximum length of series where it is consecutively present. So count will become 3. When I iterate over all these elements, I will keep incrementing the count and it will become 3. So answer for this case will be 3. Now when I come at this index, I will check if x is equal to previous plus 1. Previous will be stored with 3. I will check that 5 is not adjacent to 3. So in that case, I will increment the count. But wait, before I increment the count, you need to understand that count for now, for this thing, since it's not equal to 1, this condition did not hold true. I'll go to the else part. Answer will be stored with 3 only, because so far the maximum consecutive count was 3. That is why my answer is also 3. But now when I found 5, my count will become 1, because it is the count for any series of indexes starting at index 5. Now finally, when I come out of the loop, I will check how many moves I will be required to satisfy the condition. Minimum moves. So see, minimum moves will be what? I found when I found my answer, my count or answer so far will be stored with 3, which tells me I have 3 elements, 3 indexes at which maximum is present, right? So I have this left. From all these elements, I have only one index left which is not consecutive, or which is not as big as what I have found. So it will be better to convert this index number. So if I convert 8, from 8 I convert this to 7, how many moves I did? I did only one move. And now I have satisfied the condition that I have the maximum element present adjacent to each other. So what was creating problem? This element was creating problem because it was maximum, but it was not present adjacent to it. So the best way will be to, minimum number of moves will be total length of p array minus what is the count of your answer at that point in time, which will be storing the maximum length of consecutive indexes. So that is the number of times you will have to convert your element, and you will return that. Any doubts in this question? Let me take this example, triple two one 4 times 2. Okay, should I take this problem, or is it clear to all of you? Let me check your doubts. I don't understand one thing, why tree map gave TLE in question 3. We will come on that. Now what else? Any doubts regarding this problem? Okay, I can see people understanding this. Okay, I think Rani understood this, so I might not need to. Even if you want me to take any other example or test case, just let me know. I'll wait for 10 to 20 seconds so that I can see in your chat if there is any doubt in this question. Otherwise, I'll move to the next question. Okay, then, if it's clear, let's move to the next question. Maximum happiness. So this is your question. I'd say it is very simple. In fact, the last question we discussed, I'd rate that question better than this problem. This is simpler than that. Okay, let's see. Okay, Sujan, I'll take your example, this test case, in the end of this contest. Let's start with this question. Geek, being an awesome teacher, wants to distribute. So basically, in this question, I'm not reading the entire question. I hope you have already done that thing. So you are given a bag of a bag. This is an array of bags which tells the maximum capacity of that particular bag. Then this is the requirement array which tells that what is the need of person who needs the bag. What do I need to tell you here is that there are students with this requirement. This requirement means at index 0, student at index 0 wants to get a bag filled with, let's say these are toffees present in your bag. So this reflects that this person wants a bag with minimum 5 toffees. If you give him a bag less than 5 toffees, he will not accept it. Okay, it can be 5 or greater than 5 but not less than that. Same goes with this person. This person wants a bag with minimum 8 toffees. Now your task is to return the maximum students you can make happy by distributing the bags in the way they want. So for example, if I take this example, the output is 1, which represents that you can only make one student happy. Now you will say, how can we do this question? So see, you have, when you have requirement 5, you have bag with requirement 5 also, with 6 also, and with 3 also. For one thing is sure that 3 cannot satisfy this person. If any of the bag, if I get at least one bag, I can say that one student has become happy. So if I found a bag, let's, for example, brute force approach would be what? Let's take example here, 563 maximum happiness. This question is max happiness. Okay. So you are given an array. You're given an array like this, which is of a bag 563 and 563, and this is the array of requirements 58. Okay, this is bags. This is requirement. Now, brute force approach will be what can you try to do? You can iterate for each index in requirement array. You iterate for all the bags in bags array and check. You will stop where you find a bag with minimum this value. So when I'm at index 0, I found a bag 5. So I can say I increased the count of my answer. Let's say it was 0, now it became 1, because I can see that I can satisfy. Then also you also have to keep a track. Either maybe you can take another array which is storing the, you can say, it can be of length of bags. This is the brute force approach. I'll tell you how can we'll optimize this solution. So for example, there is another array which is storing the index that has already been used. Or let's take a map or hash set which will have the index of bag which I have already used. So index 0 has been used because I have given it to student 1. Now for student 2, you want a bag with minimum 8 toffees. So you again iterate over this array. You found 5. Although 5 has been used, there are two reasons that it gets neglected. That first of all, it has been used already for one person. And also there is one more thing. I could have, for example, this person can be happy if I give him this bag also, right? If I give him this bag also, then also he could have been happy. But where this problem will come, for example, if this was 8, okay, and I distributed bag of 8 toffees to 5. 5 will be happy, but you see 8 will not be happy because 8 cannot take 6, neither it can take 3. So this is not the optimal distribution. You getting this thing? Why this approach will fail? Because you will have not fail. In this, you will have to iterate n plus m into n times into some k times, which is the length of your set. The reason is you will have to check if that particular bag has already been distributed or not, and then from that also you will have to check if that is the optimal way. Because in one case I give him 8, in other case I can give student 1 bag of 6 and student 2 bag of 8. In this case, you see, my answer will be 2 because I made 2 students happy. So how can we solve this problem so that we don't have to reiterate over them again and again? So see, the better approach would be, let's have a look here. So your question was 563. Just a second. This was your 5. Okay. 563, right? Yeah. Fine. So what are we trying to do? We are actually in this question, see, very simple one. I think we are basically sorting bags array and sorting requirement array so that we can know what is the minimum bag of toffees we can give to any student and make them happy. If I find, while I have sorted these two arrays, right, I've sorted these two arrays, now I have used two indexes, two iterators, one to iterate over bag, one to iterate over requirements. For each index I am checking if the toffee bag is greater than or equal to my requirement, right? If it is the case, then I will iterate over the next element in bag, iterate over the next element in requirement. So increment your indexes accordingly and increment your answer accordingly, because you have made at least one student happy, so that will keep on increasing. If not, then your answer will not be updated, but only this will be updated. What will you update? You will update the index in your bags array. Got it? That is the entire solution. I think that was very easy. I hope this is clear. Let's move to the next problem. I'll just quickly show you this dry run. So what we did, we sorted the bags array 3, 5, 6. We sorted the requirement array, which becomes 5, 8. Then for each bag, I check, can I satisfy this student? No, I cannot. If I cannot satisfy, I go to the other bag. This is your K index. Can I satisfy this student? Yes. So my answer will be incremented. It becomes 1. Now what? Now you check for the other index, that is this index. Now my K is here and my this whatever J is here. Can I satisfy this student? Can I? No, I cannot. So my total answer is 1. That's all we are doing. Okay. Next question. Moving on to the next question. I think that's the last question we have. Illuminate the hall. Right? Fine. Coming on to this question. So see, what is this question about? This is a good question. You are given a hallway with the power of bulbs at every index. Zeroth index is -1. That means your bulb is not present at this index. Wherever you find -1, that means there is no bulb present at that index. Now this is index 1. It is 2. That means your bulb has a power of 2. And the power is determined in this way. See, the bulb with power x at partition I, it can light all partitions from I minus x to I plus x. So let's understand it. I'll show you. So this is your array, and what does this mean is -1, 2, 2, this is, let me write the indexes 2, 2, minus 1, 0, and 0. And the indexes are, this is index 0, this is index 1, this is index 2, 3, 4, 5. Now these are the powers, these are x's. Okay, right now if I talk about this bulb, so bulb has a power of lighting bulbs from I minus, what is index 1, 1 minus 2, the range, this is basically the range of bulb. The range of lighting, the lighting range of this bulb will be 1 minus 2 to 1 plus 2. So that is simply from minus 1 to 3. Let's write the range of these bulbs. The bulb that is present at index 1, it can lit up the partitions from index minus 1 to index 3. Minus 1 is actually will be irrelevant because we have indexes starting from 0 only, partitions starting from 0. Okay, but let's keep write the ranges of the bulbs we have. Okay, coming on at index 2. So this was corresponding to index 1. Now coming at index 2 can bulb has power of 2, so it can lit up the partition from 2 minus 2, that is 0, to 2 plus 2, that is 4. This is the power of bulb at index 2. Now there is no bulb at index 3. The bulb at index 4 can only lit up the partition present at fourth index, only one partition. The bulb at index 5 can also lit up partition at only this index, 5 minus 0 to 5 plus 0, right? So indexing will be 5, 5. Got it? You can take them as coordinates. Index 2, this was index 2, that this was index 4, and index 5. And the other indexes do not have bulbs. Now you have to tell in how many minimum bulbs would be needed so that I can lit up the entire hallway. This is my entire hallway. So see, if I choose to lit up bulb at index 2, this is partition 0, partition 1, partition 2, partition 3, partition 4, and partition 5. What is the length of the array? 1, 2, 3, 5, 6. So indexing will be this. So let's say this is your hallway, right? P1, P2, P3, P4, P5, and P6. If I choose to light up bulb number 2, you will see your bulbs from which index? Sorry, 0, 1, 2, 3, 4, 5. So 0 to 4 will be lit up. Now only one bulb is left. If I choose to lit up this bulb, now this will also be lit up. So how many bulbs did I need? I needed 2 bulbs. So if you check, you try to do it on your dry runs or some more combinations. If you try to make to lit up the bulbs, you will see the minimum number of bulbs will be 2 only. If I choose to take, for example, this bulb, so how many partitions will be lit up? Minus 1 is irrelevant. 0, 1, 2, 3. Till 3, I will have my partitions that will be lit up. Now, if I choose 0 to 4, it will be overlapping because I have already lit up all these. If I choose to take 4, 4, I can lit up this partition. Then again, 1 is left. I can choose to have 5, bulb number 5, it will lit up this. So total 3 bulbs were needed in this case, right? So like this, you will find that this is the solution with minimum number of bulbs. I hope the question is clear to you guys. Okay, fine. Then now let's see. I think this is, I hope the explanation part is clear to you guys. Now let's check how are we trying to solve this question. So see guys, as I have shown you here, we need range of each bulb. So for if I need a range of each bulb, what I'm doing is I'm creating a class pair. In the solution code, I'm creating a class pair which will have two values, x and y. For this is telling the behind partitions that can be lit up, and this is telling the basically min to max. X is minimum index it can lit up, and y will be the maximum index that particular bulb can lit up. So now I will do what? I will create an array list of pair of type pair. So this array list will be actually storing the bulbs with their ranges, where this is x, this is y, this is x, this is y. I hope this thing is clear to you. Creating an array list of pair where each pair represents the range of each bulb that are present in your given array. So this array list will only contain those ranges of bulbs that are present at the particular index. So this is how your array list of range is going to look like. Let's see here. This is your class pair. I have two values, x and y, as I told you. So x will be the minimum index and y will be the maximum index according to this thing, I minus x and I plus x. Okay. Coming on to now, this lights array is storing the pair of bulbs, the pair of ranges for each bulb. So to do that, I am iterating over the array. I am checking if hallway of I is greater than -1. That means it is actually checking the that the bulb is not it shouldn't be the case where bulb is not present. So this condition is written to ensure that bulb should be present in your hallway array. So when I iterate over this array for those values which are not -1, I am calculating their range and adding to my lights array. So lights array will take up a new pair which will have x as the x will be x will be I minus the current index I minus this AR hallway of I, and y will be I plus hallway of I. I hope this is clear. So after doing these operations, I am going to get an array list of lights like this. This is your lights array. Okay. I hope this thing is clear to you guys. Moving on to next part. Now what I'm trying to do is I am doing this comparator. I'm actually implementing this comparator in such a way that when I got this array, it should be values should be filled up in such a way that the ones that are present at x coordinate or x, those should be in ascending order. So basically my lights array is going to look like this. The one with the minimum x should be present in the beginning. So you will see that this is -1 -3, that is fine. Then I will have 0 4 because 0 will be in ascending order of -1. Next will be, I think what you see here is exactly the order in which we want our array lights array to be. The reason for this is it will actually in one pass tell me what is the maximum number of partitions that a bulb can lit up. Okay, and I will keep a track of that. How I'm going to keep a track of that? So see, let's say I'm starting off. Let me take this part of code and do a dry run. We will return lights on. Okay, then I will explain you. Fine. Let me quickly again write this example so that you guys can see. So my lights array is going to be like this. Lights array is actually an array of pairs -1 3 0 4 4 4 and 5, right? This is your lights array. Now I'm starting off with target equal to 0. Lights on is something that I will be returning. So your target equal to 0, lights initially, lights on is equal to 0. Quick dry run and starting from this index equal to 0. Now I'm running this loop while your target is less than n. N is equal to what? 6. I want to lit up maximum how many? Maximum length of my hallway is 6. So while my target is less than 6, okay, what is the size? I am doing this thing. So basically I'm starting with index 0. So maximum it can go is still 5. That is why I have put up this condition while your target is less than the length of your hallway. Fine. Then what I'm doing, I am checking. This is currently my I is at this index. If I am at the last index of my lights array, okay, or if my this x part is greater than target, then you return -1, which simply tells you that no light is able to lit up the entire hallway. Why? You will see after we dry run over all the values. Now your max range is max range for whatever I am right now. You are taking a max range variable which is storing the maximum that bulb can lit up towards right direction. So that will be 3. So right now your max range is equal to lights dot get I, which is this, dot y, that will be equal to 3. Okay, now what are you trying to do? See, you are now iterate going to check if I, this is all about whether I'm, you have two options, whether I choose this bulb or I do not choose this bulb. If I choose this bulb, right, if I choose to choose this bulb to lit up my hallway, now I'm going to check the corresponding bulbs that I have into my lights array, what all will I be needed? For example, in my next option, if I choose this, will there be any overlapping? If there is overlapping, I will choose not to take it. Then I choose this one. I can choose this. What my condition of choosing will be that it lights up only the next partitions of my hallway and does not overlap. So this is done to ensure that no overlapping happens if I choose to take that particular bulb. Okay, so right now I'm trying to check bulbs that can lit up hallway after partition at index 3. So max range consists of this 3 right now. So while I plus 1, since I want to compare the next pair, I am checking if it is within the bounds, and this x is less than or equal to target. That is, for example, it does not exceed the target, right? That is what we want to check. So this is within the targets. What is my target right now? Right now my target is 0. I started with 0, right? You have to remember this thing. One by one I will be increasing my target until it goes the maximum of my hall. So right now I'm starting with index 0. So this is 0. It is within the bounds. So I incremented the count of I from 0 to 1. Now max range gets updated to the maximum of this pair. So this is your maximum range. That means now you have gotten a bulb which can lit up till 4. That's what you are trying to do. If max range is within the target, if now I'm within this loop, I go for the next one. I check this condition. This condition holds false. Why? Because 4 is greater than your current target was 0. So I come out of loop and I check if max range is 4, it is less than target. So max range is greater than target only. So you return mine. So you don't come here, go to the next mean, which simply tells you that you have found at least one bulb, increment the count of lights on. So this lights on will become 1 because you have found one answer till now, and your target will be updated with the max range plus 1, because now, see, why plus 1? Because now your target will be to find, so far it tells you you have lit up lights till partition 4. Now you want to, you are incrementing the count of max range to, sorry, your max range was 4. You're making your target equal to max range plus 1, which tells you that you have to take a bulb which can lit up till 5th partition of your hallway. That is the reason, because I do not want overlapping. Also till 4 you have already done, so you have to find a bulb which can do more than that. Okay, in towards right direction. Now your I becomes plus plus. Your I was at this index. Where were we? Okay, so your I is at this index now. This clearly tells me that I have chosen this, then I've chosen this bulb. Now I am at this index. Okay, next partition. So this thing will keep on repeating. Let's take one more dry run and hope you'll understand. Your target is what? It is 5. It is less than your n. So it is not out of bounds. Dot x is greater than target. That's not the case. Your max range is what? Right now your max range will be equal to 4. It is 4 only right now. So you check, you compare with the next bulb. Why are we comparing with the next bulb? To avoid any overlapping. So while your this is less than size and its x is less than or equal to target. Yes, it can lit up 5, which is less than or equal to my target. So I will increment the count of my I. My max range will become maximum of 4 and lights dot get I dot y. What is the y in this case? It is 5. So your max range has become 5 now. Next what? Let's go and at this loop again. Now I plus 1 will not be, it will go index out of bounds. So you come out of this while loop. This condition max range obviously is not less than target. So one more light will be on. It will become 2. Your target will become max range plus 1, which is 6. and your I has been incremented to nth index. Now you see your target is not less than n, so you come out of this while loop and finally you will return lights on. Okay. So the intuition behind this problem was we sorted this pair of coordinates, which is the maximum range of any bulb. Then I am choosing to take ith pair as into my answer. Then I am checking the next pair if it is overlapping or not. So this part is considering this thing. If it is not overlapping, then I keep on taking other answers as well until unless it goes in a linear fashion. For example, till here it was lit, then it from here it was lit. It has to be just one adjacent, one after the other. You can, there shouldn't be any gap if you're taking answers. This is the reason we are making your target equal to max range plus 1, to tell you that the next bulb that you want to check, it should be starting from, it means the maximum, your target should be greater than max, your target should be one more than what you have lit so far, right? That is the reason. Let me know if you have any doubts so far. Guys, let me know what doubts you have. Any doubts here? Yes, you can see the code. You can have a look at the code and let me know if you have any doubts. Let me check. 1 2 0 2 minus 1 minus 1. Let's see. 1 2 0 2 minus 1 minus 1. 2 minus 1 minus 1. Okay. So see, what was our example? So we will have a pair. We will have a pair. This is 0, 1, 2, 3, 4, 5. 0 minus 1 to 1. Then we will have, this will be 1 minus 2 minus 1 to 1 plus 2, 3. Okay. Then it will be 2, 2. Then this will be 1 to 5. Then no bulbs, no bulbs. Okay, this is how you minus 1 minus 1. First of all, this is power. This is okay. This is of 0 power. That is fine. Okay. So minus 1, that is fine. This will be, now I'm just sorting it, 1 5 and 2 2. This will become 1 5 and this will become 2 2. Okay. Now what? Now we are checking if I choose this bulb, minus 1 1. So I'll have till 1, partition 1. If I choose this bulb, it will lit up till 3. Okay. If I choose this bulb, it will lit up from 1 to 5. 1 2 3 4 5 6. I have total 6. And if I choose, actually there is no bulb which is lighting up till index. No, it is fine. From 1 to 5, from 1 1. I think we will be needing two, only two, right? minus 1, 2, 3. In any case, the minimum bulbs will be 2 only. If I take 1 to 5, and what is the answer that this test case is giving? Let's see what is the answer test case gives. I think it's not able to edit it. Let me know what answer that gives. I think it will not fail for this test case. You can try it on your, you can try to do a dry run. It won't fail. Just let's see what doubts you have. You want me to paste the solution? Wait. It will be actually in 2 parts. Shall I paste it here? Where should I paste it? Let me know, guys, if any doubt is there. Else, I think we can wrap it up. Okay, this one. This was for which question? Yes, sure. Our second problem was max array. Right? Convert this. Fine. Let's take this example. 1, 5, 5, 2, 2, 3. So we have, take one page. See, 1, 5, 5, 2, 2, 3, 5, 5. Is that right? 2, 2, 3, 5, 5, 2, 5. Okay. Let's see. And your question was that you can do operations. First of all, we will be finding what is the maximum element. So the maximum element of this entire array is this, and what indexes they are present at, that indexes you will store in this another array list P. So the indexes will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 1, 2, 6 and 9. 6, 7 and 9. Now what? This is 1, 2, and 6, 7, 9. Fine. Now your target is to find the maximum consecutive indexes. So after 1 I have 2, so I can have my answer as, I can say that my answer is 2 for now. Fine. Next is I have 6 and 7. Answer in this case will be 2 again, because this is the maximum consecutive. Answer in this case is, count in this case will be 1. So that will not exceed my answer, because answer is storing the maximum of all the consecutive counts that I can have. So what will be your answer? This is 2. That means you have 5 in all these places. Now minimum number of moves will be the total length of this minus 2. That is 1, 2, 3, 5 minus 2, that is 3. That means 3 moves will be required to convert this into the desired, to fit it into the desired expectation that your problem is asking. What those 3 cases can be? See, either you can convert this, or this indexes elements by, means this was 5, right? You can, if I make them 4, if I make it 4, if I make it, minimum 3 moves will be required, and I make them 4, so you will be left with these two fives that are consecutive. What else can you do? Can, let's do one thing, let them be the same way, this is same, this is same. Let's convert these to 4, this is 4, this is 4, and this is 4. In this case also you will have only two consecutive elements, so this is the dry run for this case. 3 moves will be required. Okay, any 3 elements out of these consecutives, these this will be needed to change so that we fit it into the required explanation. Got it? Great, great. So that was all for today's contest, everyone. No, watch me code. The code is correct, it won't give the wrong answer. Is it, is the solution accepted or not? See, because if it is not accepting, that means there is some flaw in the code, but I think the test cases are set in such a way that the test cases are being satisfied with the solution that we have written. So you just have to check that. It, I agree that there are sometimes flaws in the questions, that the particular test case is not satisfied, still the question is accepted, because maybe that test case was not taken into consideration. So according to the test cases of this problem, this code will work for you. Thanks, Daya Shankar, if it was helpful for you. Shall we wrap it up, guys? Okay, then, if there are no more doubts, we'll wrap it up. Thank you, everyone. Then take care. Good night.